Okay, the second part of our notes, we're going to be solving log equations. And I've written a couple reminders for you. It says write as a single log. The log cannot be equal to 0 or a negative number, and the base of the log cannot be a negative number. And the way we're going to solve log equations is we're going to put those in exponential form. So we do have a single log, and if you notice, we don't see a base. And when we don't see that base, it's understood to be 10. So I'm going to use that whole out-back method again. So my base is 10. I'm going to go out from my exponent equals, come back. So 10 squared equals 5x plus 2. So you've now put it in exponential form. We know that 10 squared is 100. And then we're going to solve this simple equation. So we'll subtract 2. And we'll divide by 5. To get x equals 19.6. So then I'm just going to put a note right here to check. And that means to check your answer to make sure that when you plug it back in, you're not getting the log of a negative number, or if your exponent was your base, that it's not a negative base. So if we did 5 times 19.6 plus 2, that would give us the log of a positive number. So we're okay with that solution. On the second equation, you have log of 2x squared minus log of 5. So this is not a single log. So we need to use your properties that you learned yesterday. And when you see subtraction, that should remind you that we need to divide this when we write it as a single log. So we're going to have log of 2x squared divided by 5 equals 1. So now you're ready to go to exponential form. So I'm going to put in exponential form. Again, base isn't there, so it's understood to be 10. So 10 go out to the first equals 2x squared over 5. And then if we multiply by 5 on both sides to get rid of our fraction, you're going to have 2x squared equals 50, because 10 to the first is 10. So when you divide by 2, we're going to get x squared equals 25. So remember, when we take the square root of both sides, that's plus or minus 5. And then again, I'm going to check both answers. So if I put positive 5 here, that's going to give me 25 times 2, which would be log of a positive number. If I put negative 5 here, negative 5 squared is still a positive number. So both of those solutions are acceptable. For example 3, again, we need to condense those logs by using your properties. This time we have addition, which means we're going to multiply. So I'm going to have log base x of 3 times 27 equals 2. So now you have your single log. Just going to make a note, put in exponential form. So when I multiply that, I've got log base x of 81 equals 2. Now we're going to exponential form. So my base is going to be x. I'm going to go out from my exponent equals, come back to get that 81. So I would take the square root of both sides, which is going to give me plus or minus 9. So we're going to check that. So if I put positive 9 here, my base is going to be 9. If I put negative 9 here, my base is going to be negative. So we're only going to keep the x equals 9. And I'm going to make a note. Base can't be a negative number. All right. So moving on to 4. You do have a single log, and so you're ready to go to exponential form. So our base is 2, so we'll 2 go out for your exponent equals, come back, x squared plus 2x. So 2 to the third power is going to give us 8, right? So then you can see we have a quadratic, so we want to set that equal to 0. So we would subtract our 8 over to give us x squared plus 2x minus 8. I want to factor that with AC if I can, so 1 times negative 8 is negative 8. I need factors to be positive 2, so that's going to be negative 2, positive 4. My A value is 1, so I can go straight to my shortcut. So we'll have x minus 2, x plus 4. So when we set each piece equal to 0, this is going to give me x equals 2, and this is going to give me x equals negative 4. So we're going to check both of those back to our original. So if I go here, 2 squared plus 2 times 2 is going to be the log of a positive number, so that one's good. Here, negative 4 squared is 16. Negative 4 here will be negative 8, so that will be 16 minus 8. We still have positive numbers, so both of those solutions are good. Our last example, we do need to condense this into a single log. So when you see that subtraction, again, that should remind you of that division property. So we're going to rewrite this first. Log base 6 of x over x plus 6 equals 1. Then we're going to put an exponential form. So we're going to take that base, go out, come back. Okay, so we have 6 equals x over x plus 6. Again, to get rid of that fraction, we want to multiply by the denominator on both sides. So that's going to go away. We're going to have x there. Here you're going to distribute. So we're going to have 6x plus 36. So then I'm going to subtract 6x. And then we would divide by negative 5. So x equals negative 36/5. We need to check that. Back to your original. So if I come up here and I substituted in negative 36 over 5, I would be taking the log of a negative number. We can't do that. So you're going to mark this out. So can't take the log of a negative number. Therefore, in this case, we would just write no solution. And that's how you solve log equations.